Okay, good morning. In this session, we will talk about the pre-processing the data. What is pre-processing the data? The transform the previously you discussed that one. Transforming the raw data into understandable format of data is called here pre-processing the data. The best thing here is you have to handle the missing data. That means previously discussed about the all pre-processing technique. One of the technique how to handle the cleaning the data, how to handle the missing values in a data. Here, if data consists of missing values, ignore the particular row. One thing here is if you have in the data missing value, miss the some information, you have to ignore the entire row. And then other important one, fill the missing values manually. That means you will fill those values with any value. And then other important one, use global constant to fill the missing values. For example, you have a unknown value minus infinity or with the help of that one. And then other important thing, use mean value. For example, if you have the number, if you handle a number data, you have to fill with the mean values. And then attribute mean for all sample belongs to the same class. And then other last important one here is for filling the missing values, most probable values to fill the missing values. That means you will take the some of the most probable value range values, like that, most probable values. Here I am going to take an experiment here. Pre-process the data in WEKA with the sample experiment. The first experiment here is handling the missing data. Here the data may be numerical data as well as the nominal data. For the both numerical data, that means the data sets consist of numerical data, some missing values are there, and then nominal data, some missing values are there. Here, how can you handle such kind of missing data? For missing data, you have a different steps are there. Here, handling the missing data, you have a different steps. Mark the missing values. Here, how can you mark the missing values? If it is a categorical data, nominal data, you have to mark the missing values. And then second important, remove the missing values. If any missing values are there, already you discussed that one, missing value, and then replace the missing value with some other value, or mean value or average value. Here you have to replacing the missing value. The first one here is a remove the entire tuple or mark the tuple. For example, if it is a categorical data, if you have any missing values in a categorical data, I'm going to missing that data. For doing that one, go to WEKA. Yeah, go to WEKA. Here, this is WEKA. Click on Explorer. Click on Explorer. That means it takes some time. Yes, it will open the Explorer. Yeah, it will open the Explorer. Next, go to, that means it is automatically pre-processing step. It is in click on pre-processing step. Open the file. Here you will open the file. That means it is in location, data set. For example, I am taking the missing values data. Here, if you observed here, the current relation, the relation equal to some CPU, and then instances equal to, that means it consists of number of rows 3, and then some of the weight, and then attributes. It's having the 8 different attributes. If you want to view this one, this data, see here, this is a some relation. For example, the vendor nominal data, and then nominal data, and then numerical data, and then max numerical data, coach numerical data. But luckily here nominal data not having any missing values. You have to fill the missing values. If it is a nominal data, how can you fill that missing values here? If it is a nominal data, replace that one. See here, the missing values replace. For example, open the Explorer, load the data. That means I am taking the German data. Next, I can explain you German data value. What are the missing values, and then I can replace that one. And German data, and then click on the numeric clean. That means unsupervised, go to unsupervised attribute, numeric cleaner is there. Here, after that, you have to performing these steps. Indices values. Okay, how can you do that one? First, you have to do the explorer. Already open that one. Here, I opened the explorer. That means if you want to verify that one, click here weather dataset. The weather vendor not having any missing values. The vendor attribute not having any missing values. Here coming to the second attribute. If you identify that one, yes, he also not having any attributes. Here coming to the third attribute. If you comes to the third attribute, not having any missing values. Okay, here if it comes to the fourth attribute, see here, there is a one missing value, 33 percentage. Here the M max consists of one missing value and then numeric type. That means for the numeric type only having the missing values. Here and then another important, the fifth attribute also coach also having the one missing values. And then other attribute also having the missing not having missing value. And then coming to the seventh attribute, not having missing value. Here eighth attribute having the not having the missing values. That means totally you have a three missing values in our data set. Here my intention here is replacing the missing values. And then if it is a the first step here, if you have the any missing values in a categorical data. Here uh, for example edit this one. If it is a edit this one, vendor having the any missing values, then you have to apply the next. I am telling you some step, applying the step. Here what are the step here? See here, close this one. Here what are the steps? Here load the data. The second important step in this case, load the data. Go to the load the data and then choose here filtering. Click on filtering and then after click on filtering, go to unsupervised. Unsupervised, go to unsupervised. Under the unsupervised attribute, go to unsupervised. Under the unsupervised, go to attribute. Here you have a numeric cleaner. Here, see here, numeric cleaner. The numeric cleaner, if it is having the nominal data, having the missing values, luckily not having any missing values. If it is a numerical data, that's why you have to fill like this. Here, what are the conditions? Already I applied some conditions here. Open the WEKA Explorer. Here, up to this one, filter the configure data. Here, attribute indices. See the attribute indices. Here, click on here, attribute indices. Here, click on the attribute indices. Here, attribute indices to index the attribute first to last. Here that existed here, first to last. And then second important, minimum threshold to close to zero. Whether this one is a all not, minimum threshold. Here the minimum threshold close to zero or 1 point something is there. I am close to zero. And then the next important step in this case, here is a minimum default to NAN. Minimum default. This value. Why? Because if we have any missing values, text data or string data, then only you will apply this one, NAN. That means for that purpose, NAN, and then click OK. OK. And then those values, for example, if you having the any value in a vendor missing data, that means I can explain later. Any value in a vendor missing, then that replaced with NAN, replaced with NAN. But luckily not all our numerical data uh, missing values are there in our data set. Okay, the next important step, the next important, what is the next important process in this case? See here, that is a thing. That means what are the steps you did? First, you go to the WEKA filter. After that, numeric cleaner. Click on numeric cleaner, and then click on here. You will identify this one. The minimum threshold 0, default value NaN, and then save it. Okay, and then apply this one. If you apply this one, if you have any information, that information converted into NaN, the text data having or nominal or categorical data having the any missing values, that data converted into NaN. That is a process. They are luckily not having any data NaN. The next important one, what is the second step? Removing the those values. Here for example, in the come to the second step, remove the missing values. If you have the missing values here, missing values, remove that values. How can you remove that values? Here unsupervised instance, and then remove with values. Unsupervised instant, remove those values. Here do that one. Here for remove the values here, for example, edit this one. You have a one missing value is there, another missing value. That means every row consists of missing value. If you remove the all missing values, nothing was there. So remove step, I can tell you remove step. How can you remove that one? And go to filtering. Under the filtering, you have a unsupervised. Under the unsupervised, you have a instance type. Under the unsupervised, unsupervised instance, instances. Under the instances, remove the value, remove with the values. If you click this one, here it will remove the all values for the data. Here apply. If you have the any value missing here, modify this one, apply this one, remove, apply, remove. That means in this way you will apply. Final one, the final step here. Coming to the final step, replacing the remove value. Very important step. Here if you have the missing values, you have to replace with some other values, or mean value or mode value. Here I'm going to replacing that value with this one. These are all, this is a step. Here for replacing the replacing the or removing the value. Next, first of all, you have to data set. The data set, open the data set. Here missing values are there. I'm taking the data set. Open that one. And then here I'm going to apply. Go to this one. Same. Go to filter. Under the filter, you have a unsupervised. Under supervised information is there. Unsupervised. Go to unsupervised. Unsupervised. Go to unsupervised. Go to unsupervised. In the unsupervised, go to attribute. Under the attribute, remove missing values. See here, remove missing values, replace missing values, replace missing values. Click on replace missing values. If you want to see the value here is a debugging value, ignore. Debugging false, ignore. That means replace missing values for the nominal and numerical attribute in a data set with the modes and means from the training data. Here with the mean value and mode value, you have to replace in the data. You may use any data. That means you are going to replacing the values with the mean. Let us assume. Apply this one. Here, that means before applying, what is the data set? You have to see the data set. Here, in particular data set, one row missing the M max, second row missing the M minimum, and then third row missing the CACH. That means three values missed here. That means I am going to replacing that values. Apply this one. If you apply this one, here all missing values replaced with the mean value. For example, if you edit this one, see here, Here you will identify this one. Previously, there is a missing values information is there, but now not having any missing values. That means replacing the missing value with the mean value. That is a replacing method. I think clear for you. Okay, next important talks, all types of normalization. Min-max normalization, Z-score normalization, decimal scaling normalization. Coming to the first normalization step. Here, the first one here is what is a normalization here? The normalization is a process of rescaling one or more attribute to the range values minus 1 to 1. That means any type of value. For example, salary value 4,000, 3,000, 6,000. That value is converted into 0 to 1 or minus 1 to, sometimes we may consider the minus 1 to 1. This means that the large value for each attribute, for example, salary always not exceeding the one value, and then smallest value here is a zero. That means that is called here normalization process. Any type of values, but means it's applicable on the only numerical value. Any type of values converted into some 0 to 1 range, that's called here normalization. Here all attributes of data set can be normalized with the WEKA. Here you have a three different types of normalization available. One is a min-max normalization, second one here is a Z-score normalization, and then decimal scaling. First one, min-max normalization. Here the min-max normalization means, here for example, when the limit attribute value unknown, that means you don't know about that. That means 4,000, 6,000. That means that can be converted into range value 0 to 1. You have to converting that particular range value 0 to 1. Here for converting min-max normalization, you have a formula. New value, I want to identify the new value. For example, you have a 10,000 salary, 9,000 salary. Among those different salaries are there, I want to identify the 20,000 salary details. New value, that is there. New value equal to original value minus old value divided by old maximum. That means original value, that's it. New value, original value minus old minimum divided by old maximum minus old minimum. This is a formula for that one. That is called here min-max normalization. For doing that one, you have a different steps. For example, open the WEKA and then load the data set. You are not taking the German data set, I am taking the any reference data set. And then filter, go to filter. Under the filter you have a normalized drop down box is there. That means unsupervised attribute filters, and then left click, open the normalize. After that, click on work. That means it is a numerical data. Perform normalization on all numerical attribute. Here it will perform, is there any nominal attribute, is there any categorical attribute, you cannot perform the normalization. You will performing the normalization on a numerical attribute, and then scale that value into 0 to 1 range. That means maximum value, minimum value. See that one, I want to see that one. Go to WEKA Explorer. I am loading the data set. Here previously you load the data set. Here what is the data set you previously load? This is a data set. The data set consists of some of the new, these are all numerical values. Some of the numerical values are there. For example, these are the numerical value. Here otherwise load the data set. Open the data set. Open the missing values data set. Here for example, you have some missing values are there. Here if you have the missing values, replace the missing values with mean. How can you replace the missing values with mean? Go to this one, and then go to filter. Under the filter, go to unsupervised, click on unsupervised. Under the unsupervised, replace, replace missing values. Replace missing value, click on replace missing values, apply. Yes, replacing the missing values with the mean value. Yes, replace the mean value. This is a data set. What is my intention? You have a different values are there here. Min, m min having the different values, and then m max having the different values. Those values converted into 0 to 1 range. Those values always converted into these numerical values I want to converting is numerical 0 to 1 range. How can you converting that one? You follow the different steps converting. Here, what are the steps for converting these values 0 to 1? Go to filter. Here, click on filter. Under the filter, click on unsupervised. Under the unsupervised, you have a normalize button is there. Click on normalize button. Here under this one, click on normalize. Click on normalize. Here click, if you click on normalize button, here you have a some information is there. If you see here, the WEKA generic object editor, if you open the editor here, normalize all numerical value in the given data set. That for the particular data set, here normalize the values and then debugging false, and then scale. Here the scale equal to 1.0 and then translation equal to 0. That means minimum value 0 and then the scale up to 1. Here before applying, I am editing this one. These are all different values are there, and then I'm going to converting this value, apply the normalization. That's called here min max normalization. Apply this one. If you apply this one, if you edit this one, editing this one, the values change like this: 0 to 1. All values are in the range 0 to 1. 0 to 1, 0 0.5, 0 0.6, 0. That means it's not verifying the class label values, only verifying the these independent values. It will normalize the independent value, not a dependent value. Here the class label here is a dependent value. Here all values converted into 0 to 1 range. That is a min-max normalization. Coming to the next type of normalization here. What is the next type of normalization? Z-score normalization. What is the Z-score normalization? Data standardization. The data standardization is a process of rescaling the one or more attribute so that they have a mean value 0 and then standard deviation 1. See here, mean value as well as the standard deviation. Here but means you require that one. Here mean value equal to the formula. This one here is a mean value equal to original value minus a mean value. Here I'm considering as a 0. Standard deviation equal to 1. That's called here that is the for doing the process here, data standardization. Here the normalization used to when minimum maximums are not known. I don't know about the minimum value. I don't know about the maximum value. That particular cases we're using this one. This is a formula for the Z-score normalization. Here, what is the Z-score now? This is a formula. New value equal to original value minus mu, in the sense mean value divided by standard deviation. And then how can you set that one here? Here open the WEKA, load the data set, and then go to unsupervised. Click on filter, unsupervised, attribute, go to attribute and then standardize. Click on the standardize and then apply and then save that file. Here for doing that one, go to WEKA Explorer. Here if you want to open the, that means already you have done some information on this file. Open that one, another one. For example, open another file. Say take another file. For example, I'm having the student data set. Okay, if you want to see the same information missing values, see this one. Here this is a data set. Where did this data set? The data set consists of some of the missing values. First, non missing removing the missing values or replace the missing values. How can you replace the missing values? Here click on select button. Click on select button, unsupervised. Under the unsupervised attribute, replace with the missing values. Here replace the missing values. Yes, apply. Replace the missing values. Here see here, the replace the missing values with the mean. Apply, replace the missing values. Next important thing, standardization. What are the steps for this one? uh, First step, open the WEKA and then click on source button, standardize. Standardization. Why? Because 0 to 1 range, you have to standardize the values 0 to 1 range. For doing that one, here click on this one, go to unsuper filter. Under the filter, go to unsupervised. Under the unsupervised, you have a standardize. Here, see here, click on standardize. Click on standardize. Why? Because previously you have a, this is a data set. Before applying the standardize, this is a data set. Here, see here, the standardize consists of the standardize the all numerical value, not a class value, all numerical attribute in a given data set, to have zero mean and then unit variance. That means from the class attribute itself. Here for doing that one, here see here debugging and checking values, same as it is, use that one and then click apply. If you edit the data set here, all are standardized here, standardized to these values. Here see here, these values are standardized to -1 to 1 range, -1 to 1 range. This is a jet score. um, this one is a just score normalization. And then the next important normalization here you are considering here is a decimal scaling normalization. It is a process of dividing the attribute values by a constant that brings all values into the acceptable range. That's called here decimal scaling normalization. For example, if you have a range -40 to 120, then dividing by 120, you will have the values -1 to 1. Dividing 120, that means here the value v of the attribute a can be normalized by in the following formula. This is a formula for the decimal normalization. V of I by 10 of j, 10 power j. That means I is a some value and then j is a unpredictable value. This is a something about the pre-processing. Thank you.